ratio in there. So it says let the summation of a sub n be a series of non-zero terms. Then the series converges absolutely if the limit as n goes to infinity of the absolute value of a sub n plus 1 divided by a sub n is less than 1. And it diverges if the limit is greater than 1 or infinity. Some people put the or infinity here, but to me, infinity is still bigger than 1, so you could just put that first part instead. However, it is inconclusive if it equals 1.
So this is basically like just a continuation of the
limit comparison test.
Okay.
Kind of, yeah. It's just a little bit broader. We tend to use our ratio test for powers and factorials. Which remember we looked a little bit at last week, our factorials. It is one of the last tests that's on your flow chart, and that's because we just don't use it quite as often, because again it's really only helpful for ones that I can't use anything else for, which are going to be your powers and your factorials, and we don't usually have a ton of those. So it does help us in very specific cases where we can't use anything else, but it's probably not our most used one. Our most used one is probably our P series, just because it comes up a lot in and of itself, as well as in our in our direct comparison test. So that's the one you probably see the most often. You ready? So it says determine whether the following series converges or diverges. So what do we have? What do we have in these? Factorials and exponents, right? So the first thing is especially with factorials, that's automatically gonna eliminate any of our other formats, right? It's not going to be geometric. It's not going to be P series. Okay. Also, because of our factorials and our, it makes our nth term test kind of hard to take the limit of that. We're not going to be taking an integral of a factorial. Also, they're not alternating, which is what makes it slightly different. So I can't use my alternating series test. Which is why I said that they're kind of this thing in and of themselves, and why we end up usually using the ratio test. But they also work out pretty nicely when we use the ratio test. So our ratio test tells us that we want to look at the limit as n goes to infinity of what? What's on the inside? Absolute value of a sub n plus 1. So what am I doing with that n plus 1? What does a sub n plus 1 mean? What goes here then? I'm not going to put an a sub n plus 1. I need to actually do that for the problem. There we go. So I'm going to plug in an n plus 1 wherever I have an n. Yes, that's what a sub n plus 1 means. Okay. And then what are we doing?
Dividing by the original a sub n.
Cool, which is the same thing as? so I'm gonna have my n factorial on top. Right, this makes it a little bit easier because it's not so like big. Do we notice why this might be helpful? What is diagonal from each other? The factorials and the exponents, right? So if I can rewrite that in such a way to like have things that are factorials and things that are exponents, then we can probably reduce some things. Yes? Okay. First off, we need to think about if I have 2 to the n plus 1, how can I rewrite that?
2 to the n times 2 to the 1.
Times 2 to the first, right? By exponent rules, basically we're doing our exponent rule backwards. Usually we multiply until we add our 2 exponents, but we can also do that backwards, okay? On the flip side, do you remember what n plus 1 factorial equals? How can I break that apart?
In factorial plus or time. Wait.
Multiplication.
Times
N plus
plus
1
1.
times n factorial.
Yeah.
Because if I have 6
Yes.
factorial, right, I can take out the 6 and I'm just left with the 5 factorial. Okay, so I take out that first term and then I'm left with the rest of it factorial. Are we okay if I drop my absolute values? Do you agree that exponents and factorials are going to be positive? Yeah.
Yes.
So my first one is now going to become 2 times 2 to the n. My bottom will become n plus 1 times n factorial. Which is helpful because now what happens? We can reduce some things. My n factorials reduce and my 2 to the n reduces. So what is that limit going to equal? 0. Okay. So what's my conclusion then? So this is less than 1. So therefore, my sum of 2 to the n over n factorial converges absolutely by the ratio of those.
How many points do we lose if we didn't put the absolute?
Technically on this question, none, because it doesn't ask if it's absolutely convergent, it just asks if it's convergent.
Is this our only test that's absolutely convergent?
On our alternating one, we looked at absolute convergence versus. For that one, there's not technically a test in and of itself. We just take the absolute value of an alternating series, and then if that converges, then it is absolutely convergent. But yeah, so this is the only one that's the only test that technically gives us absolute convergence. Was there another question?
Something absolutely divergent.
I guess
Or
we
it's
don't
just-
technically call it that, right? So because we have absolute convergence, which is where the absolute value and the original converge.
Mhm.
We have conditional convergence where the original converges but the absolute value does not,
Mhm.
and then you just have divergence.
Okay.
So basically, like, because that middle one is like 1 is not and 1 is converging,
Yeah.
right? We just call that one conditional convergence versus divergence means they both diverge. Alright. What are we gonna do on the next one? Again, we have a factorial. Are most of our other tests gonna work if I have a factorial? Not really. Okay. So we're gonna go to our ratio test. Ish, yes. But this time when I plug in an n plus 1, yes? What are we gonna have there? N plus 2. Do we agree that that is, that my absolute values are redundant? I can drop them? Okay. Alright, what can I simplify my n plus 2 factorial to?
N plus 2.
Okay, times.
N plus 1.
Okay. And then what are we gonna have at the bottom?
3n plus 3.
So 3 times 3 to the n. Okay. What's that gonna equal? Hmm?
Infinite.
Infinity. Do we all agree with that? That my n is on top, so if I am having an n that's going to infinity, then the whole thing will go to infinity. Okay. And infinity is what? Bigger than 1. It's real bigger than 1. Therefore, what can I say?
Infinite divergence.
It diverges. By the ratio test. Questions on that? Okay. This one says, show that the ratio test is inconclusive. So what are we looking at? Okay.
Could you not just simplify that?
Yeah, maybe.
Oh, okay.
Just not for this problem.
Correct.
Is that a cube root?
It is.
Okay.
So, do I have to have my absolute values this time? Can a cube root be negative? It can. I am starting at n equals 1 and going to infinity, so if I'm only plugging in positive numbers, is it going to be positive?
Yes.
Yes. So, but we can go ahead and leave them since we have that cube root. What am I going to have in my first fraction?
N plus 1.
N plus 1 divided by
The cube root of n plus 1.
times.
The cube root of n.
Okay. What do we have to do there? Do I have stuff with cube roots in it? Yeah, I have two sets of things stuff with cube roots in it, yeah? Now, my cube roots, I can't do like I did with my factorials and reduced stuff. However, I still do want to put them together. also group my other two together, so n plus 1 divided by n. Yes, no, baby? Are we okay with that? Like, I haven't done anything besides just rewriting it a bit. And remember, the nice thing about our limits is that they are different than our derivatives and our integrals, that I can multiply limits together, yes? Which is nice. So I can look at those two things kind of separately. Yes, no, maybe? Yeah. Is a cubed root going to be a continuous function? Yeah, as long as I'm past 0, yeah. So am I allowed to bring my limit inside of a continuous function? Yes. So I'm really just looking at the limit as in, or as n goes to infinity of n divided by n plus 1. What is that? 1, right? Because I have an n on top and bottom. We could do L'Hopital's rule. We get 1 divided by 1, right? Which is 1. What's the cube root of 1? Also 1. And then what is the limit as n goes to infinity of my second one? Also 1. Right? Because this one we could just break apart, right? To be 1 plus 1 divided by n. That second limit is going to be 0. So I just have 1 plus 0, which is 1. So 1 times 1 gives us 1. Which means that this is what?
Inconclusive.
Inconclusive. But as Addie said, what could I do with this instead? Okay. So what does that equal? Okay, so I have n, so it would be 1 minus 1/3, right? So we get n to the 2/3. So if I had that, we're not going to do it completely, but if I had that, what test would I want to use then? Can I do this?
Wait.
I can't do geometric, so remember geometric is where our base is a number and our exponent is the variable, right? But is it a p-series though? Because it's not a fraction, right? Is that? Hmm? I mean, I don't know off the top of my head. I would probably start with the integral test because that's going to be pretty easily integratable, right? Yeah? The antiderivative, that's going to be pretty straightforward. So that's probably where I would start with that one. So, speaking of, when we're choosing a test, right? Because again, for the most part, we are not going to be told, use this test, right? No, baby? So remember, you do have your flow chart. So basically the first thing that we want to look at is it a special type? What are our special types?
Harmonic.
Yeah, harmonic is a specific case of the what?
P-series.
P-series. So I have P-series. What else? Geometric. We technically added another kind. What's also a specific case? Yeah, our alternating is also a very specific case because I can only use my alternating series test on an alternating. We technically can, for an alternating series, if the alternating series test didn't work, we can use our root test, but for the most part, our ratio test, for the most part, we'll use the alternating series test for that one. Now, if it's not strictly one of those, our next kind of question is, can it be compared to special series. And if the answer is yes, then we probably want to look at if I can use my direct comparison. Yes? You can also think about, does the n term approach 0? So what happens if my limit as n goes to infinity does not approach 0? It diverges, right? And then lastly, if none of those work, then can we apply integral for ratios? Like I said, in your book, and sometimes if you're looking at online, they will also cover the root test that is not on the AP test though, so that's why we're not technically covering it. The other reason why we don't cover it is because a lot of times you can use the limit comparison test instead of the root test. Alright, so let's look. Alright, we are not actually going to choose these. Do you have a question?
It was just like, do we have to state by the telescoping whatever test if we ever use that?
If you were actually using that it was a telescoping, yes. But the AP test also doesn't have telescoping. Alright, so it says look at the guidelines and we're just going to choose which one we would use. So we're not actually going to test the divergence or convergence, we're just going to pick which test we would use. Okay? So on A, I have pi over 3 to the n power. What would we do? Geometric. Okay. What about B? What would we want to directly compare it to? Okay, so we're thinking about 1 over n-ish, right? 1 over n is harmonic, so it is divergent, right? So if I'm wanting to compare it to a divergent, then that means my original has to be greater than that, right? So can I say that 1 over 4n plus 1 is bigger than 1 over n? I also can't even say 1 over 4n is greater than 1 over n. So can I use that one? Well, what's our other one? What's the other comparison test?
Limit comparison.
The limit comparison test. I have a problem. So it does look kind of like one. We couldn't do the direct comparison, but we could use our limit comparison. And that will be there. Okay, what about for C?
Why do we want to use the limit comparison? Is that not going to equal 0?
This is what we're going to equal 0.
I don't think we need to
Because if I divide them, right, your n would, you would end up being able to use L'Hopital's. With division, yeah.
what would be
1 over n.
So you can just get rid of the 4?
Because you would be multiplying by the reciprocal. So then we're not stuck with n's in top and bottom. And so we can use L'Hopital's after that. And so you would end up with, depending on how it works out, either a fourth or a 4, right? Because you would have a 4 in front of one and not in front of the other one. which does equal a number. Therefore, since 1 over n is divergent, the other one must also be favored. Sorry, part C. Go back. Before that. Our nth term, what's that limit gonna equal? 1/4. Does that equal 0? No, so that means that is divergent. So what about D? I wouldn't, because the n on top is gonna make that funky. I would do the integral test. This is one of the cases where you would use the integral test. We don't just use the integral test on everything, though. Because again, remember, taking the integral of stuff, especially an unbounded integral, takes much longer than just using our p or geometric series. I know you did, but you do a lot. It takes. Remember, we were looking at a time test, so. Alright, what about E? Alternating. Okay. Now, our next one I'm just gonna give to you. So this is one where like your book might recommend to use the root test when you have a whole bunch of things to the nth power. If that makes sense. Because then I would take the nth root of it. It's not super hard, but that's probably what they would use. But what we can use instead is we can also use a limit comparison test, and you would compare it to just what would I compare it to? Like 1/3 into the end, probably. But like I said, that one is not going to come up a lot because my test nor the AP test is going to give you something where you would really have to use the root test. And then what about that last one? Ratio. There's a factorial there. It would be.